So once again, very good day to everybody. This is Algorithms 1, and in today's class, we'll be discussing about the brute force computing as well as string matching. Once again, this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we'll discuss about the brute force approach. Actually, in the beginning, we'll discuss something theoretical with regards to the advantages and disadvantages of this brute force. Then in this class, we discuss about the example program about the brute force approach, how we go for the string matching, what are the various string matching algorithms, and in the string matching algorithms, we'll be discussing about the pattern searching and then about the naive pattern searching algorithm. Okay, so we discuss about the best case and worst case. Then I have some independent work for you. You have to complete them and submit them in the Google Classroom well on time. And as I discussed earlier, you have time extra 1 month also you have time, because I thought okay, November end is going to complete, but definitely with the way it goes, definitely it will go up to December. Okay, so up to that you can complete your independent works, and I have at regular intervals some short videos to discuss the knowledge in our topics. Right. So this is brute force algorithm. Of course, it's a straightforward technique. Whenever you have brute force, you are going to develop the states that are associated, and we will be identifying all paths, like different paths, like maybe left we have one path, right we have one path. Maybe if that is not the optimal solution, or maybe if that is not the desired solution, then maybe we take the next path. But in all of the procedures that we try to follow, we go with the minimum short path first, which is nothing but MSPF. Okay. So I can even say that it is OMSPF, optimal minimum first path. Okay, shortest path first. Okay. So maybe let us take in the case, maybe you are trying to optimize some books in a rack. So according to the possibilities, according to the order, according to the name that you will be shelving in a library. Even our daily day-to-day activities is all about brute force nature that we will be experiencing, and we will be having optimal algorithms. So it is not only about the shortest path, but it is all about the best solution that we are providing, and it is all about the minimum steps that we are taking in order to find the desired solution. Okay, and this works by the best case. So, for example, if best solution or maybe best case is reached, which means that it stops finding. Okay, so maybe for the example part, you can try about finding the best path for the traveling salesman problem. This is very important for you guys for your real time application. Whenever you are going to practice this, finding the best path for the traveling salesman problem. Anywhere you go into the world, they will be asking this one. Try for this one, maybe use the brute force and find the optimal minimal solution. Okay, and you have satisfying also. So maybe if not only the best solution, like if you have a satisfactory solution for your problem even, then definitely you can stop on to this one. And of course, traveling salesman path that I told you falls within this 10% of the optimal, which is close to the optimal path that we are designing. Okay. So definitely brute force algorithm definitely requires exponential time. Exponential means it is in steps. Maybe like one step, maybe it goes for two steps, then it goes for four steps, then 8 steps, 16, 32, 64, 128 and so on. Okay, but definitely our approach should be finding the minimum shortest path, and we have to find the optimal path. Okay, right. So we try to optimize all these, we try to find out all the procedures associated with this, and we find the explode path. Okay, so this is the example. Okay, this is the example. Here we begin with the root node. So maybe we will have A, B. So A will have C and D. C will have G and H. B will have E, F, and then K. Okay, so this is how it goes. So what you have to do, you have to find the minimum optimal shortest path by this method, okay, by the brute force approach. Okay, so how you are going to do, you are going to begin with the root node. Okay, you are going to go with a and b. Okay, a it goes, okay, then after a we have to take the path c or d, it goes to the next step. Okay, so it goes to d. Okay, like after d there is no nodes that are present. This is not the optimal solution. It goes back, it retracts back, or it goes back to a once again, and then it goes to c. Then after c it goes to h. So after h, it's not the desired solution. Once again it goes back, it goes to c. Now it goes to g. This is not the desired solution. Once again it goes back. So this is what, until you find the best solution, it will go back, go back, go back. Okay, so it will go back from g to c, c to a, then again to here, then it will go to b. Okay, so then you have e, and then you have f. Okay, so it goes to e. Okay, afterwards there is no node, goes back, goes to f, then goes to k. So you have to find the desired solution with the minimum steps. Desired solution. For example, this one. Okay, like if you go to e or maybe f or maybe a or maybe like a d or maybe c. Okay, the path should be minimum, and it should have only one solution that is associated. Okay, so in this case, if you can see a b, a has c d. Okay, after d nothing, then you go to c, g, and then h. Okay, after that there is nothing. Okay, we are not getting an optimal solution out of this one. Once again we go with b, e, and then f. Okay, and afterwards k. So in this case k is considered as the desired or maybe the optimal solution. And if you can see the number of steps that are associated, 1 2 3 4 5 6 7 8 9, this e from k, totally there are 10 steps that are associated. And in order to start from the root node to the k, okay, so k is the desired solution with minimum 10 steps. So that is the optimal solution by the brute force approach. Okay, so this is what is explained here. Maybe from the starting position we have choices a and b. Then maybe it can go either with state a or maybe state b. In the case of state b, we have e and then f. Okay, so it goes, every state is considered step by step, one by one. So that is the depth first search. Okay, so the depth first search is nothing but going, backtracking, going to the previous one where there is no desired solution. Once again it goes, it considers the below states, then it goes for the feasible solution, then starts from the root node, then go to b. Okay, then e and f. Okay, so here if node c does not provide a feasible solution, no point in g and h. Then backtrack to c, then to the a. Okay, then we go on to d. Here no solution. Once again it goes here, b. B has f and e. Okay, then from e you can go on to the k, which is the desired solution. If you count the number of steps, if you can calculate, it will be 10. So that will be the minimum steps for this brute force approach. Okay, so definitely it is step by step. Okay, you will be getting the correct solution. You will be going step by step. It is nothing but listing all the possible candidates for the problem. We are not leaving out anything. We are going for all possible solution, and if the desired solution is not reached, we backtrack, we go with the depth first search. Okay, so it's a generic method and used for simple problems as well. So for simplicity you can use for the brute force approach. Okay, so the real disadvantage of this problem is that it goes for the order of n or maybe order of growth. Okay, so because normally for the previous algorithms, maybe linear search or maybe binary search, you can go with order of 1. So that is the best case that you will go. But here it will consider all the cases. Only after that only it will go for the best solution. So It relies more on compromising the power of the computer system, and definitely brute force algorithms comparatively, if you compare, then definitely it is slow. It is not constructive or creative, it is just step by step going along the steps. Okay. So this is an example program where you will try to demonstrate. Actually, you are going to find the pattern in the search string. Okay. So it's a C program. You go with hash include stdio.h string.h because we are going to search for the pattern. Abdul Qasim John, please don't fight. Okay, then you go with the define max 100. You try to find out the given pattern in the search string. Okay, so it's you're going to go with the brute force, in brute force character search character pattern. So actually in the input you are going to input the pattern and then the search. You are going to find the string length and the pattern length, and accordingly you will find, okay, where the location is, okay, whether it is present or not present. So pattern is the array to be searched. It's nothing but the whole string. Okay, so maybe we will have three variables int I, j and then k. Then you will have the for loop for I equal to 0, I less than or equal to string length minus pattern length I plus plus. Then you go with the inner loop for j equal to 0, you assign k equal to I, and you search for this pattern k equal to pattern of j. Okay, then you compare this j is less than pattern of length, because in the complete array you are going to search for this pattern whether it is present in that length. Okay, so if it is present means, if j equal to pattern length means, then you return j, and in the worst case you go with return -1. Okay, you terminate out of the loop. Okay, then you will go with the driver code in main function character search string of max pattern of max in the residual function. Okay, result print f enter the search string. Then you try to go with the f gets, you will go with the search string max the input, then print f enter the pattern string. First you are going to enter the search string, then you go with the pattern string, you try to input the pattern, the maximum and the input. Okay, and finally you go with the search string, the string length. Okay, search string is -1, then you go with the pattern string length pattern -1. The result is nothing but the brute force. You will go with the search string pattern string length of search string string length of pattern, and maybe if it is not equal means you can show search pattern is not available. If in other case you can show search pattern is available at the particular location. Okay, so this is how it goes. So the earlier case we saw step by step, here we are applying step by step, and we are finding whether in the total array we are having that pattern or not. If it is present means, then you will show search pattern is available in this particular location. Otherwise you go with that -1, search pattern is not available, you go with return 0. So enter search string, God is great, enter pattern string, great, this one. Okay, so it is present, so you can show that the search pattern is available at location 5. So this is how it goes. Okay, actually here if you can see this grade, okay, it's at the 5th location. Okay, so up to God is it's actually discarded, starting from grade. Okay, I mean the before of that it is going to take, that is the location 5. Okay, then you go with the string matching, pretty much aligned with what we have discussed with the case of brute force. Okay, so it's actually a method where you can find a location or maybe a place where one maybe you will have the several strings that can be found in the larger string. So you consider a text array, maybe t of 1 to n, okay, of n character, and maybe a pattern array p of 1 to m. Again I'm telling you, whatever we are discussing string matching is aligned to that brute force approach. It's aligned, we're finding the pattern out of this one. Okay, so the problem is to find the integer s, what you call it to be the valid enumerate shift for the s value, that the shift ranges from 0 to n minus 1, and the text array that is from s plus 1, s plus 2 up to s plus m to be equal to the pattern that you are searching 1 to m. Okay, so maybe if you have to find the pattern in the text, so which means that pattern should be definitely a substring of the text array that you are finding. Okay, so here the item of maybe p and then t are character from the finite alphabet. So maybe like 0 to 1, or maybe A capital B, A B Z, or maybe small a b z, you can find any patterns. Okay, maybe a series of zeros and ones you can search, maybe 0101, maybe if you want to search in that pattern. So what pattern it follows, that you find the location. Okay. Actually, if I can show you with an example, you will try to understand better. Okay, so let me show you the algorithm or maybe the procedure out of it. Okay, so the proper substring of this string t from 1 to n, it is actually t of 1 to j for a mathematical condition I. Okay, varies from 0 and then j varies from n minus 1. Both I and j varies from 0 to n minus 1, and the t of I j, the pattern you are waiting to search should be equal to the entire array. Okay, within that it should be a part of the, or maybe it belongs to, or it is a subset of, okay, the string that you are searching. Okay, so it is t of I, t of I plus 1, t of I plus 2 up to t of j for I and j from 0 to n minus 1, the case. Okay, so we'll have different algorithms for this one: naive string matching algorithm, Rabin-Karp algorithm, finite automata, or maybe Knuth-Morris-Pratt algorithm, or maybe Boyer-Moore algorithm. So in this class, we'll discuss about naive strings matching algorithm. Okay. Right. So this is the basic thing. Okay, basic factors. Okay. So maybe let us take in the case we are having a text of maybe a length n. We have the text from 0 to n minus 1 and the pattern from 0 to m minus 1. Okay, so we are producing a function search, maybe the character, the pattern, character, text. Okay, you assume that the text size is greater than the pattern size, so that is the reason you specify n greater than m. You are assuming, you are pre-assuming that n is greater than m. Okay, let us take in the case the text. This is a text and pattern is nothing but test. Okay, so in this case where the test is there. Okay, no, location, for example, it is part of this one first of all, and if it is part of this one, then you should find the location. Okay, so including the empty spaces up to here, you find the test. So that is the reason you will have 10. For example, another text you have AA, BAA, CAA, DAA, BAA, BA. For example, you have this text pattern. Okay, pattern is nothing but AABA. Where are the AABA present? In the first it is present, AABA. Start from the beginning where the pattern is present. For example, in the beginning you see AABA. So it is at location 0. Okay. Another one you have AABA. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. AABA. Ninth position. Again, if you see AABA, this, but normally many of them you will fail. Like this last pattern, you will maybe you will misunderstand. Okay, this one only you will take, the other one you will leave. Okay, but everything it will check. So that is the reason 0, 9, and then 12. Okay, so this is how it goes. Let us have this one. Okay, like the text. Okay, as I'm telling you, 0, 9, and 12. Okay, right. But in the program you will have a small change in that. Okay, so that will go. Okay, so this is a C++ program for the name pattern. Okay, so search algorithm, hash include bits slash std c++.h, using namespace std function, void search, it is character pattern, character text. You assign m to the string length of pattern and n to be the string length of text. Okay, so I told you once again, text is greater than pattern, or maybe pattern falls inside the text. Okay, so you have a loop for sliding this pattern. Okay, pattern function one by one. Okay, so for int I equal to 0, I less than or equal to n minus 1, because m falls inside m. Okay, so that is the reason n minus m, and then I plus plus. Then you will have int j function. For the current position I, check for the pattern match. Then you will go with the inner loop for j equal to 0, j less than m, j plus plus, and if text I plus j, because this one every step it is going. Okay, so if it is not equal to pattern j, then you go with a break, you go with the next one, that's all. Okay, you go with the next one. And if this j is equal to m, then you find pattern found at the index, the location. Okay, so it is not going to leave any variable, it is going to go step by step, irrespective of the numerical value, irrespective of the capital numbers, irrespective of the small letters, it is going to go with each of the steps. Okay, so you have the driver code in main function, character text, this one, and this is the pattern that you are going to search. Okay, so then you'll go with the search pattern comma text, then you break return 0. So this is the thing, pattern found at index 0, pattern found at index 9, but here pattern found at index 13, because this one 9. Okay, this is 12, this is the search. Okay, but this string it's common here, and so you cannot share. So that is the reason C++ will leave this one and it will show 13, but logically speaking it is 12. Logically speaking, it is 12, but you cannot share the two strings, so it is going on to 13. Right. So the time complexity which is associated is order of n square, and the auxiliary space is order of 1. So it is considered as the best case. So maybe the first character is not present, means it is going to the next one. Very time consuming process. Right, and similarly we have the this one also, like order of n. For example, it is going to take n time. Okay, like FAA is not actually present, so it is going to take n amount of time. And maybe worst case also, maybe when all the characters of the text and the pattern of the same, so maybe a will have pattern also 4 years. Okay, so that also happens. Okay, so worst case also happens when only the last character is different. For example, here if you can see a and then b. Okay, so this one. Okay, so number of comparisons, order of m multiplied by n greater than m, so n minus m plus 1, so it will take extra one step even to identify. Okay, so even if you try to compare with other algorithms, like we had different algorithms, out of all this one, Knuth Morris Pratt algorithm, you can go with this one. In order to improve the worst case, you can go with this algorithm, but other than that, Nave's pattern is very good. So these are the independent works, Python 3 strings, and then let's complete them at your best available time. I'll be checking them. Okay.